Hello, ST. I'm making this a small sort of like a small tutorial about how to create a solderable area for specific layers of the PCB. Either it can be top or bottom part of the PCB. So this is actually the I make it this area example. So for the solderable area, so you can do it two ways. You can do a hatchet or just solid. But I was reading information about the hatchet that some people say that it's a lot simple to how you call it. This is the area you can see. There are some examples of the hatchet area. This is a little bit more advanced than you can see the hatchet. I think this is created with another software. Actually, Spring Layout 6 can actually do that hatchet area. You can see there's some areas. Maybe this is a bit more advanced. You can see some hatchet areas, but hatchet area in our application is to reinforce the flowing of current, because we had a bank of capacitor that they are going to deliver voltage and current. We need the current to be with less resistance as possible, micro resistance as possible. So the area we cover, solderable area, will reinforce that area. I already did it, so I was reading they say that it's a lot easier to solder in this particular matter than the other way. The other way it might bend the PCB, but this is a lot easier to solder. Just apply a little bit of layers of solder, and you can tell it's going to be a lot easier to fill up those hatchet areas on the PCB. So I already did it today, but I'm going to show you how to do it, so you know how to actually do it yourself. So okay, I'm gonna do the same thing here with this example. One example, I'm going to use the S2, the seal screen mask, the bottom part, just so I can see what I'm doing, and then I'm going to turn it into a copper. After I turn it to copper, then I'm going to apply the solder mask with this button right here. I see sort of like a red pad. It's solder mask. So I'm gonna create it right now. I'm going to make the hatchet or solderable area, but I'm gonna make a hatchet. Sorry with that. Okay, here you go. So just something quite fast. Just gonna make it fast. There you go. So that is the solderable area. So what we usually do, turn it into copper, and then I'm gonna select the solder mask to apply a solder mask to that particular area, and now that area is going to receive solder. All this, but the problem here is that when you apply solder to those specific areas, it might bend the PCB. So to avoid that problem here, I'm going to create a hatchet. So it's going to be hatchet, and then I'm gonna give it a number, so to make it a little thicker. Let me see, I think it's up here, outline. Let's go with 1 millimeter, and here I think it's 1.30, 1.30, or maybe more. Maybe make it so in a way that it's going to receive solder. And it's going, I'm trying to say that it's going to be a lot easier to solder these like this than all with it was going to take a long time to solder the whole thing, but with the hatchet method away, I don't know how to say that word. Anyway, we had that. Let me see, 1 millimeter. Let's go with, okay, you can increase it. You can change the numbers here to make it bigger. You can tell you can make it a lot bigger. I have seen this on audio amplifiers for a long time, because I used to dumpster dive basically here in Puerto Rico a long time ago, and I opened the amplifier and look at the PCB, and I was so curious about this thing, why it has those areas. Like I seen this on CB radios, Cobra radios. I have seen this. The application, I think they use it to reduce the magnetic wave, I think, but also it will help for the soldering. It's going to be a lot easier to solder those areas if you have a hatchet. So it's going to create like a little lumps of solder instead of solder the whole thing. So here you can actually select it and you can edit the way you want it. As for now, I have 1.40. It's 1.40. Okay, let's see. I think I can make it thicker. 1.60. We got 1.60. Let me see. 1 millimeter. I think that's fine right there. Okay, let's go with 1 millimeter. 160. So you can apply solder there. You can see that area is going to have solder but hatchet. It's going to have solder but hatchet. Also, I have to edit this one here to make it same as the other one. This one here, the bottom one, it says, okay, 1 millimeter outline, 160 width, 1 millimeter outline. Okay, 160. So they are going to have the same properties right there. So we have the hatchet ready to go. Yeah, I think that's good thing that I was looking for the information. Oh, you can take off the hatchet. It's really simple. The only thing you gotta do, just take off the number, but you can go back. You see, it's quite simple. Hatchet, I think hatchet is a great idea for the PCB. It's going to have all this area is going to have a solderable. It's going to be solderable area and a lot easier to solder, like I mentioned many times. I had to mention that many times. Okay, we have a little situation on the sorry, but I forgot to go back. I did create the mirror image from the standoff that you placed already. They look really nice, but we have a little situation. I decided to add this area, cutout area for the PCB. I think it's fine because we have how many? 1, 2, 3, 4, 5, 6, 7. We have 7 spots for the PCB to be secure, so that's fine because this PCB is going to be rigid anyway. But we have a little problem here because this transformer is on top of this standoff. So I'm not sure what should I do. Should I go? I'm not sure what should I do here on this situation. But we have this screw hole here, so I'm not sure what to do. Maybe I really don't want to make the PCB too big. As you see, I had to. I don't know. I don't have much space. Not much space here to work with. So we have this screw right here. Unless we eliminate this one, I really don't want to do that because maybe we can move this one up a little bit. So we can move this. No, this. Yeah. It's this one here. We only need to move this screw standoff up a little bit higher, but we cannot touch this capacitor. Oh man, don't tell me. The alignment is perfect. The alignment here is perfect. Oh, let me see. Oh no, it's not that really perfect. No, it's not. Let me see. Hold on. I would say that it was perfect, but it's not. Yeah, it's a little higher. Yeah, it's okay. It's okay. I thought it was perfect for a second, but they look about the same. Let me see. Hold on. Let me see this one here. I think this. Let me see. It should have one. Let me see. Hold on. Let me see. We got here. Yep, it's the same. This is the same. It's okay. They don't need to be perfect. They don't need to be that symmetrical. But the most important thing is that they need to match the PCB, the top part of the PCB, the STO. That's the most important part right there, the STO. So unless we move this screw up there a little bit more, so I'll be able to move this transformer higher a little bit more. But I noticed that the head of the screw, the M3 screw, is not that big. The head, hold on. Okay, I gotta keep checking. M3 head screw, screw head size. Oh my god, let me see. Metric strength, what the hell is screw? ISO. Okay, let's see. The M3 screw head size Phillips type. Okay, Phillips type is 2 point what? Really? No, not gonna be. A, letter A, 6 millimeters. So it's 6 millimeters. I'm sorry about that. So okay, we have 6 millimeters, and this is bigger than 6 millimeters. So this, hold on, let me a second. So this one should have 6. This is 7.5. So this is 6 millimeters. Oh, maybe no, yeah. Depending on, see, you are going to use a M4 screw. The M4 screw, depending on the situation. M4 screw is 8 millimeters. Let's see, 8 millimeters. Okay, that's the size of the. We just have a few millimeters to work with. So that means sorry about that I had to move this screw, this standoff up, so in order for the transformer to fit there, so we can screw all this. So let's do that. Let me see. Hold on. So that means I gotta copy the. It's easy. It's easy. It's not that difficult. It's easy. I can do that right quick. Hold on. Give me a second. I'm gonna move this. I'm gonna move it. I'm talking like it's someone there for real. I'm just like, it's just okay. It's fine. Alright, I'm gonna select everything. It's fine. Everything is selected. Okay, the transformer. We need to move this, so we need to have space for the head of the screw. Okay, let's see how big is this one here. This one here is 10 millimeter. It's fine. This one is 10 millimeter, so we have plenty of space there. So we need to move this screw higher. Okay, let's go. 1, 2, 3, 4, 5, 6, 7. 7. I think 7 should be just fine. 7 times. We need to move it 7 times. So that means gotta go back to the master file and move it up 7 times. I don't think it's gonna work, but I'm gonna try. Hold on. So man, this look really good. Okay, we gotta move it 7 times. Okay. Oh man, this is sad. I really don't want to move it. 7 times. Oh Lord. Okay. 1, 2, 3, 4, 5, 6, 7. Oh yeah, that's it. Just a little bit more. It's fine. But it does not need to be aligned with the other screw. The most important thing is that those need to be matching the top part of the PCB. This is fine. So we can fix it. It's okay. Nothing to be worried about. This is fine. Nothing to worry about. All right. So I need to remove the seal screen so I can see what I'm doing. All right. Did I move that? Okay, I move it. Okay, let's see how this is affecting the others. Oh, I see what you did there. Let me do this area first. Okay, cool. This should be thicker, right? Okay. Okay, I think you did this number right here. You see, guys, Mr. SD is doing a good job. Also, you guys can do the same. And he just started a few weeks ago, and he's doing really good. You just gotta have patience. That's the only thing you gotta have patience. Lot of patience. Lot of patience. Okay, I can fix this. Okay, I can use a small grid. I'm gonna use a smaller grid here. Okay, I'm gonna use a smaller grid so I can enable these to go higher. Oh yeah, that's fine. That's fine right there. Okay, good. Okay, I think I need to fix something. Oh, I see. That's the hatchet area. Yeah, I gotta fix the hatchet area. Don't worry, guys. That's the hatchet area. Okay, it's okay. Cool. Okay, hey, hold on, man. Hey, man, come on, man. Come on now. Don't do this to me. We can make it better. Come on now. Come on now. Come on now. Come on. Come on. Come on. Give me that 90 degree. I need that 90 degree. Let me see. Do I need to have the 90 degree. It has to be a 90 degree. Let me see. Let me see. Let me see. Okay, let me see. 90 degree. Yes. Yes. We got 90 degree, guys. You see that? Look amazing. Okay, so we need to fix this one here, the red one, this copper area. It has to be fixed. Okay, so we need to place the alignment is not that correct. Let me see. Hold on. Oh yeah, thickness 30 millimeters. Oh, the thickness is not the same. It's fine. It's fine because I'm working now with the top layer, so it's fine. It's fine. There's no need to be the same as the bottom part. Maybe yes. Maybe I gotta see what is going on here. Okay, this is 30 millimeters, and the other one is what? This one is 13 also, but it's not the same grid. I need to make sure that the grid is the same. The red one should have the same grid. It's weird. Maybe it's just something about the software maybe that we need to fix here. Alright, so we continue here working with this layout so you guys can see the way we do it. It's not science fiction. It's you just gotta do some brainstorming. That's the only thing you gotta do. Brainstorming, thinking about the designs. Oh shit, it's fine. Don't worry about it, guys. Don't worry about that. There is always a button for that. Okay, I see something here. Okay, let's wait for that to normalize. It's fine. I think we gotta make this thicker. Okay, continue working with this area. So we need to move this up here. Alright guys, you see what I mean? You gotta sort of like adjusting the areas of the PCB. Okay, this might be a bit difficult to accomplish. Let me see. I'm gonna try here. Okay, let's see. Okay, come on now. Give it to me. There you go. 90 degree. Okay. No, a little ugly. Let me fix it. It has to be aligned with the. Come on now. Give it to me. I want to see that line. Okay, it's a little ugly here. Oh, I see why. We gotta do this number. There you go, guys. Okay, a little higher, maybe. Oh yes. Hold on, guys. Hold on. We can do it, guys. We can do it, guys. It's not that difficult. So the only thing I gotta do here. Okay, this is difficult because I need the grid. All right. So here I can actually rotate it. Start angle. Let me see. It's 235. Let me try to. No, 235. Sorry about that. It's the other one. Stop angle is this one here. Stop angle 180. Let's rotate that a little bit. Okay, I see some spot. I don't like this spot to be here. Oh man, this is going to be difficult. Oh, there you go. Okay. Yes, that's it. That's fine. That's fine right there. Perfect. Fine right there. I'm happy with that. So, okay. The only thing that these two lines, they are not aligned each other. I don't know why. For some reason, they do not align. So this is 13 millimeters. The thickness is 0.80. Okay, we got 0.80, and this one here, 0.80. I need the red one. So let me see the red one. No, it's the same. For some reason, they do not match. Maybe it's not a big deal. Guys. Okay, we got that figured out, right, guys? You see that? So now, what I need to do is basically copy this area. It's easy. It's really easy to export this. So I'm gonna okay, this is okay, build group is good. So I'm gonna make a line. I'm gonna create a silk screen line, and I'm gonna place it here in this center. Wait for, okay, there you go. It's good to go. So now what I'm going to do is just select all these, build a group, and then copy this data. So I need to remember that I need to delete that. Alright, so now I'm gonna place it here, paste, and we had the guy, it's guided already, so I can delete this one here. I'm gonna delete it. Oh, what the hell happened here? I see what happened. I forgot. Okay, guys, I'm sorry about that. Okay, I gotta press Alt key to select the one that I needed to edit. So I'm going to use the grid of this line to place it here, so they will be matched. There you go. So now it's good to go. Good to go. You see that, guys? It's not that difficult. The only thing, you gotta have a lot of patience. There you go. So it's fixed. No, not yet. I still gotta move this. Let me see. I'm gonna try. We just need a few more millimeters. Oh man. Okay, let's see. 1, 2, 3, 4, 5, 6, 6. Oh man, so close. So close. I think that's perfect right there. Because the head of the screw is not that big. Depending on which standoff we are going to use, the M4 is 8 millimeters in diameter, the head for the Phillips screw. So this one is more than that. This is hold on, give me a second, guys. This is okay, 7.5. Okay, we need 8. That's fine. Perfect. There you go. There you go. 8 millimeters in diameter, the head of the screw. Depending and we are using the M4 screw. You see? Good to go. It's good to go. Well, because we made this line a little larger, but I think we can make it smaller. So I think I would say 8 millimeters in diameter. So I think I should edit that so we don't get confused. We don't want to get confused. So let me get delete this one here. It's done already. We had isolate the standoff. We are talking about Mr. ST. He was doing that too. He was doing some editing here. Okay, the ST did a good job. Oh yeah, definitely. Very good. Oh yeah, I think he did some other extra editing here. So all right, so good to go. They don't need to be perfect. The alignment from here to here is not really needed. We just need a support for the STO PCB. So it's good to go. All right, so we fixed that. And now, oh yeah, hold on. What happened here? I see some movement. Hey, what happened here? Did I move something? Oh, I see. Let me see. Hold on. What happened? What the hell happened here? Oh, I moved something here by mistake, guys. Don't worry. Let me fix it. This is the cutout of the STO PCB. Build the groove, and then there you go. So that's the cutout, the outline of the PCB basically. Maybe I can move it. No, I cannot move it like that. So maybe I can edit this PCB. So this, okay, hold on guys. Okay, let me see. Split the group. It's not too great. What the hell is going on here? Split the group, and then I'm gonna edit this area to make this PCB smaller. Oh, depending on the situation, because I might need some more space to place all the components. I had the MOSFET, Q1 MOSFET, and we are need to place so the rest of the components, the optocoupler, the relays, the resistors and stuff like that. So I might need some more space here to place the components on this area, depending on the situation. Depending on the situation, depending on how tight it's going to be. Because I still can edit this. I can just go like this. Once I'm going to show you, I can just go like this and cut what I don't need on the PCB. So the idea that I have now is that after I complete the connections, I will see if I might be able to reduce the size of the PCB the best I can. So I fixed the problem of the screw. So the screw is higher now. This one here in particular. So I gotta let him know that I moved this. No, probably, yeah. I'm a dumbass. I'm making the video to show him about that. So he probably see this. Alright, so that's done right there. Perfect. Plenty of space. Now I understand why he made this this outline. This outline is 10 millimeters, so that is a good idea. That's a great idea right there. So we had the isolation for this. The isolation for this. Good. Very good. Very good. So I gotta continue working with this. The connection for the supply, for the optocoupler, for the relay. The relay is going to replace the switch. It's a 12-volt relay. And let's see if I will have enough space for all this circuit. So the project 16 circuit. So I will see if I might have plenty of space. I'm not sure. Probably not, but I will see. I will see. Oh yeah, that's done. So that is done. Hold on, give me a second. Let's make it symmetrical, guys. Okay, hold on. This one is fine. This one we can leave it like that. We can. This full screen indicator is just fine. We're gonna leave it like that. Oh yeah, look awesome. Look at that. You see that? That look amazing. Look at that. Okay. Alright guys, so I will leave it like that. But on the STO software on circuit, I'm gonna change the shape or the size of the seal screen. This one is 10 millimeters. It's 10 millimeters too. Oh, okay. It's good. Good to go. Good to go. The head of the screw is 8. It's 8 millimeter maximum size, so it's good to go. All right. We got it. All right, I'm gonna stop the video. We'll continue working with this. I think I needed to concentrate now on the connections and stuff like that. And also, I need to concentrate on how I'm going to make the connection for the switch. I found the switch online the other day. Let me split the group so you can see so you guys can see what switch I use. This is the part number of the switch, and this will be just fine for our application. Instead of having jumpers, we only need to have a hold on, give me a second guys. I need to click on the okay, so we had that's the MOSFET, I think. Yeah, it is the MOSFET. So that's the switch. I made the macro for the switch. So it's plastic, so it's going to be insulated, so you don't have to worry about touching that because it's made of plastic. And this should be just fine because this is 3 amps, 125 volt AC. So I don't think the transformer is not gonna drain a lot of current. So I was reading something that this particular component, this particular transformer, for the 230 volts, it uses a 100 milliamps fuse. So I was really curious about that. So I need to place a fuse for this small transformer. On the information right here, okay, that's the primary. Thank God the guys from this website, they told me that I need to connect for the 120 volts AC for USA connectivity. I had to connect pin 1 and pin 3 and pin 2 and pin 4 for 120 volts. For 330 volts, you gotta connect pin 2 and pin 3 together. So That's why this is going to be the easiest connection, is this one here. After you select the switch down, it means that the pin 2 and pin 3, they are going to be connected. So for the 120, I gotta figure out how I'm going to do that. So I need to feed both circuit, but I need to see the configuration of the switches. So I really don't want to make a mistake here. So I need to know that after I flip this switch up, this is going to be off, no connection here. And after I place the switch to this side, so that means it's going to look like this. Okay, hold on, guys. Let me illustrate you guys. For the 120, I had to make this configuration. And you can see both switches should be on to the, I think it's to the left, right? It's to the left. For the 120, for the 230, both switches should be like this. You see what I mean? That's what I'm trying to figure out right there. So that is the switch. And then let me continue with the transformer, and it says something about the 100 milliamps fuse. So right here, let me zoom here, guys. Let me zoom. Let's see what the hell's going on here. Okay, what is the thing that, so I can zoom here? It won't let me. Oh, I'm a dumbass. All right, let's see. Okay, so this is the part number 6351. Is this one here? And 9 volt, 133 milliamps. Okay, no load, 11.1 volts. Okay, no load. Okay. Weight total, the grams, efficiency, external fuse 100 milliamps, standby at 230 volts. Fixing screw is an M4 threaded screw, so it needs an M4 screw to secure the transformer. Hold on, let me see the dimension of the hole. I need to make sure that I have it larger than for M4 screw. I think you see what I mean, guys? It got 4 millimeters right here. Okay. Hole screw. M4 hole screw. M4 hole screw. M4 hole screw. Topics. Clearance hole. Clearance. It says in metal industry for M3, okay, 2.5 millimeter hole in standby for 3.5. For M4 screw, this is sharp right here. Okay, let's see. Oh shit, sorry about that, guys. Thread size, tap drilling, thread size, tap drilling, thread size, tap drilling, threads. Okay, hold on. Okay, M4 screw, tap drill. Size 3.60. I have 4 millimeters. I need to know the hole, not the drilling, not for tapping. I'm not doing tapping. I need to know the hole clearance, mechanical clearance, hole clearance. Okay, M4 4.3, close fit, medium fit, free fit, 4.8. 4.8. Okay, the hole is 4. Let's go with 4.8 just to be sure. 4.8. So that's the hole. So I don't want the, you know, this might be silly for you guys, but when you do a design, you gotta make sure the screw can go through with no problem. Imagine if you order the PCB and the hole is way too big, and then you have to drill it. It's gonna look messy. It's not gonna look nice. So you gotta make sure about any small details on this design. So let me see all the information. Wait, hold on. No, that's making a screw thread. We don't need that. We don't need a screw thread. We need the dimension, the whole dimensions. That's what we need. Okay. Okay, screw size. That's what we need. M4 screw. It says 3.3, but that's for tapping. I don't need the tapping. I need the information of the screw. That's all I need. Okay, I see that. Okay, let me see this one here. Nope. Hey, man, this is so. It doesn't say nothing about the whole dimension. Should I ask the guys again? I think I should ask the guys. What will be the whole dimension? Yeah, I think that will be the correct thing to do. They ask them then what it will be the PCB hole diameter for the M4 screw, threaded screw. I think I should ask the guys just to be sure 100%. For now, I'm gonna leave it as 4.8, so the screw can go through with no problem. So I'm gonna leave 4.8. So let me write it down here. What the hell I'm doing? 4.8 millimeters for a hole. 4.8 millimeters diameter. For now, I'm gonna write it down here just in case. Just in case. You gotta be M4 screw. Yes, M4 screw. The information, I'm gonna leave it here. I'm gonna rotate it. No, it's fine. The other one. Okay, no. What? No. There you go. Whole 4.8, 4. Yeah, I think that's fine. Alright, I gotta continue here. So I fixed that. The PSS 3.4 is almost done. Almost done, guys. Almost done. So we need to be sure 100% that all is good to go before we order. Actually, Mr. ST is gonna order this PCB, so we need to be sure 100% that everything is fine, there is no mistakes, nothing missing. Okay, I think it looks great. Yeah, it looks great, really nice. Hey, hold on, I'm looking for something here. Maybe he was trying to do it just. Oh, those are markings. I'm not sure if he wanna do the cutout. I'm not sure, because I saw these markings here. Maybe it's just measurements, probably measurements. But he was doing right there. All right, I'll save this. I will continue working with this PCB. At least I fixed that. All right, guys, have a good day. I hope Mr. ST saw what I did today. It takes a lot of thinking. All right, guys, have a good day.